All right, we are underway here. So welcome, all of you. My name is Brennan Lodge. I am a VP data scientist at Goldman Sachs. I lead our SIRT team, so that's Security Incident Response team for Goldman Sachs. So my background is in both data science and cybersecurity. And today we're going to talk about homegrown machine learning implementation for the SIRT. So kind of like a journey presentation here of starting up a data science team within our SIRT, and then going through that implementation, a little bit of education for our cybersecurity guys. And it's been a fun ride for me that continues on. And kind of a sexy topic here of both cybersecurity and data science, but we'll jump right into it. So who am I? Brennan Lodge. There's my Twitter handle there, blodge8. Feel free to contact me there. I'm also on LinkedIn, head of data science for our SIRT team. And again, SIRT is Security Incident Response Team. I may throw out some cybersecurity lingo, so apologies on that. I'll try and talk through some of those short terms or technical terms. I have a master's from NYU, MSBA program of 2015. I've also got a couple articles that I published in 2600 magazine, a popular hacker magazine. And recently also joined a consortium called AIRS. So that's the Artificial Intelligence Risk and Security. Quite an interesting consortium that we've started up, and feel free to reach out to me after the presentation here. But really, we're a bunch of financial services. We've got 7 banks, 4 tech firms, and 2 universities with about 35 members now. We plan to release a white paper this quarter, so be on the lookout for that. But a little bit about AIRS and a quick plug here. So it's financial services, academia, technology group coming together to start a dialogue really about AI and ML and risk and security, and the implementation of that corresponding to mostly the financial firms and risk and considerations for formulating an AI strategy for the financial services industry. So feel free to ask about that after the presentation. Happy to take those questions. So quick disclaimer, the views and opinions expressed in this presentation of the presenters do not reflect the official policy or position of Goldman Sachs. Just have to state this here. So the agenda, we've got 12 minutes or so left here, but want to talk a little bit about cybersecurity, provide some context, and then get into the data science lens into cybersecurity, which has been a fun journey. And then we'll deep dive as far as we can on some of the detection evaluation, so that cybersecurity attacks coming in and using data science to help with evaluating those attacks. And then a particular use case, a fun one that we are taking to production right now on DGA detection. So DGA, in case you want to Google real quick, is domain generating algorithms. So here's a good funnel I like to talk through that gives some context about what goes on in a security operations center, also called the SOC. So we're dealing with tons of logs, tons of systems, servers, desktops, databases, and all those logs are coming together for us to detect suspicious or malicious activity within an enterprise. Now, my background is in the financial services. I've worked at JP Morgan Chase, the Federal Reserve, Bloomberg, and now at Goldman. So I've kind of pigeonholed myself into that enterprise cybersecurity landscape. But it's very similar for these numbers and figures across that spectrum. So millions of events each day that are coming in. Those events are filtered down by some logic written by engineers and the cybersecurity analysts to identify new trends in attacks, new types of vulnerabilities that are being disclosed. And that funnels down to like 3 to 5 really severe alerts each month. And the majority of those alerts, and unfortunately, are false positives. Those false positives can be anything from a system account trying to log in, hundreds of thousands of times, to a regular user forgetting their password, trying to log in. And especially with the work from home dynamic, because of COVID, the threat landscape has changed, and we've had to adjust to that threat landscape, for better or worse. But in all, cybersecurity is really hard, and it's tough to get a handle on security. And what data science can do is bring in a better handle, be more objective when handling these types of cybersecurity events, to fuss out some of those false positives, and really drive up the true positives, and help our analysts investigate the events that they really need to investigate. So a quick walkthrough of what the SOC is, Security Operations Center. So a lot involved there. To give you like a physical view of a SOC, at least in the banking industry, anywhere from 5 to 25 different analysts working in a room, looking at a monitor, usually a big dashboard in the back, a big screen monitor that has visualizations of how many events per day, any high severity events coming up, any email, phishing attacks, DDoS attacks, network, right? So to be an analyst in cybersecurity, you've got to know quite a bit of technology. That could be from application development to networking, to engineering, to server administration, to desktop administration. So a lot of those technologies coming into one SOC for us to investigate those types of potential attacks. And those events usually roll up into what you see on the left here is the SIM. So that's the Security Incident and Event Management. And then all the other components of a SOC, everything from the log collection to reporting to threat intelligence being what's going on, from nation states, China, Russia, the Middle East, any of those particular attackers or threat actors, as they call them in the industry, trying to come in and attack. So combining all of that into one, and then investigating that activity. So the data science lens comes in to help with, first and foremost, the data. So again, here's kind of breaking that down a little bit further. Those logs, the cases, the events, all come into that case workflow, and that's the SIM. So what's our problem? Tons of detections. Many SOCs, at least in the banking industry, have anywhere from 300 to 1,000 different detections that they write to analyze different types of attacks and malicious and suspicious events. So with that comes a lot of noise. So if we can, and what we've been going on in this journey is integrating a comprehensive analytics platform to better identify what those events are, as far as what our, when I say our, like what our systems are, what the crown jewels are, and crown jewels meaning what's the most systems that can be compromised that we want to protect, and then narrowing in our focus on those systems and identifying the vulnerabilities and patching, and then investigating. So data science methods here as a solution, we can empower the analysts to work on higher fidelity alerts. So how do we do it? Well, we continue to get bombarded with the attacks from the hackers. And then a quick mention on the insiders here. So an Edward Snowden kind of look on both the threat vectors that we have to prevent and investigate. And the data scientist is coming in to help this data analyst that's sitting on the seesaw and getting launched off the seesaw, because it's never a perfect balance between defense and detections, to provide some sanity with the investigations that they have to do. So as far as the implementation goes, and now we're getting to the crux of the presentation here, a lot of things that, when I educate, some of the leadership about how do we use data science for the good and for cybersecurity to help our analysts, well, here are some of the blocks or the pieces that we need to bring together. And a lot of leadership is asking, well, what about the ML? Well, we can't deploy ML unless we have an infrastructure, unless we have our monitoring, unless we have ML ops and some tools and feature extraction. And the ML code, as many of you guys know, is just a very minuscule part of the big part of the implementation here. So here's our take on implementation that we've been having some success with. We first started out with understanding what our data stores are. So everything from Hadoop, Kafka, Splunk, any of your open source solutions that are holding or storing the data, we need to build connectors to them in order to bring that data in so we can do some abstraction. So we've written these custom codes and connectors to bring those in. Then we'll write Procmon jobs or automated jobs to bring them in on an hourly basis, daily basis, what have you. And a lot of them are different types of code. So they're APIs. Python has been the glue to help us out. We also used Spark, open source there, and PySpark to make these connections and use some of the open source big data solutions for streaming and that. So the feature engineering, once we've got that data pipeline built, we're taking in some of that data and using Jupyter notebooks to do some of that development type work, understanding some of the features and the data, doing some correlation strength against usually supervised models here, so that labeled data, and then the tough part about cybersecurity and the data there is it's not always labeled, or if it is, we have a very small, minuscule amount of actual attacks that we can model after. So we've got to do this balancing act of trying to bring in some good training data that has some of that attack type labels, or we may have to create our own. And then when it comes to the ML deployment and prediction, we're using some open source tools like Omega ML for that deployment of understanding and tuning the accuracy. So we're doing the confusion matrix, and it's a lot like the medical field in that it's very severe if we do get a false negative. So that would mean an attack happened and we didn't detect it and missed it. So in that bottom left corner of the confusion matrix, we're always trying to gauge how we can reduce the false negatives. But on the other hand, if we have too many false positives, then our analysts are just going bonkers and haywire because they've got a huge number of false positives and they lose trust in our ML that we're trying to deploy. So again, back to that seesaw, right? We're trying to do the balancing act here. And I think it's the best of both worlds where you have your human ingenuity, because these analysts are super smart. They know the ins and outs of the systems, have that tribal knowledge. But if they can get some assistance from the ML on context to guide them to make better decisions on those investigations, then it's a win-win. So on the integration part, again, we talked about this data connector. Here's an example here of that interoperability of trying to make some code to then connect to all these different data sources. Our ML platform, heavy in the ML ops, so our data scientists are wearing many hats of engineering, ML ops, cybersecurity expert, data science, analytics, you name it, we're trying to accomplish it all. But this is the basic flow of our future engineering, our model deployment, bringing in those model metrics, and then making those metrics available to our analysts. Because they need to know if they're marking false positive alerts, and we get that feedback system to help with our ML deployment and get that higher accuracy. So real quick, want to get into DGA detection, which is a fun one that we're rolling out. So DGAs are domain generating algorithms. Those are used by malware family. So this is very common in the attacks like ransomware that you may hear in the news, where a company gets attacked. So ransomware, meaning an attacker gets into a system, will compromise a system, encrypt their hard drive so they can't get access to it, and you'll need a password, and usually you need to pay Bitcoin to get that password. But prior to that attack mechanism going through, once an attacker compromises a system, that will usually beacon out. So it beacons out, communicates out back to the attacker system, what's called a command and control system. And usually that system has a link or domain. And to avoid detection by the cybersecurity teams or the blue teams, that domain will be scrambled letters, numbers, and sometimes slashes or what have you, similar to what you see in the bottom right there of the Tiny Banker DGA. Tiny Banker is a type of attack and malware, but you'll see there that it has a seed or a regex that's known by the attacker, that's actually coded into the malware, and it uses an algorithm, and that algorithm uses random things like the stock price of the day, the interchange rate between the dollar and the pound, for example. So it randomizes that to create that weird looking domain. So why not fight fire with fire, or an algorithm with an algorithm, and use an algorithm and a machine learning detection to detect DGAs? And that's exactly what we're trying to do here. So here again is another example. And we can break this domain into features. So the features can be the number of letters in the domain, the number of vowels, the number of consonants. Are there any English words? What is the TLD or that .eu? And it's kind of like a linguistic type of exercise, but it's been fun trying to create and re-engineer these algorithms that are created to generate this random set of URLs. And we're doing just that. So again, here's another example of a DGA. In the bottom there, you see some of those domains. Emotet is a type of a DGA, a type of algorithm. Again, uses CNC or command and control channel. And if we're able to detect this, then we're able to prevent some of those ransomware attacks right there. So if they try and beacon out to this particular domain, well, we've got a block in place because we have a probability to say this is a DGA compared to a Google or a Yahoo.com, right? So again, here's some of the features that we used. And then at the bottom there, we have a probability score of benign or DGA. And then we're able to do a multi-class to see what type of malware family and did it truly match a DGA from our repository. And this context, again, is huge for analysts. So we're not only providing, yes, this is a DGA or a particular family, a malware family that it may be associated with it, but we're providing the context as to why we think it's a DGA and some of the features that we used in our prediction algorithm to guess against that. So with that, we've got 3 minutes left. Went through quite a bit of implementation of data science and cybersecurity, how cybersecurity is helping out our analysts with data science, and an example of a use case of domain generating algorithms and using an algorithm on the defense side against the attack algorithms that are being used by attackers, in particular ransomware. So I'm going to take questions in the Q&A, and yeah, feel free to reach out to me afterwards. There's my email address and Twitter, but we will take any questions at this moment. All right, don't ask all at once here. No questions so far. right. Thank you, Andrew, for your message there. Very interesting. Thank you. Hope you got something out of it. At least learning about cybersecurity and data science.